Hi, folks. Sorry for the delay. We were waiting for participants to join in. Uh, we'll just get started right now. Ronak, turn on your screen. Yeah, I'll just share my screen and get started. Hello, everyone. So, if the screen is visible, can you please type in the chat if the screen is visible? Uh, I just want to communicate with you. Okay. Okay. Cool. Cool. So thank you everyone for attending this session in generative AI, and also thanks to Raja for giving me this opportunity to present you about the knowledge in generative AI. And first of all, a very happy New Year to all of you. Uh, and yeah, let's get started. So, talking about myself, my name is Shubhro Kamal Das, and I've been an AI researcher at Voxing University for the last 6 7 months. And I'm also a co founder at ProjectX.cloud. I mainly handle the finance and tech at ProjectX, and also I'm the head of GDSC AOT right now. And I've mostly worked in the field of AI in finance and AI in tech, and AI in healthcare. I've also worked with Mr. Asparik at Hospital for Special Surgery at New York City. That was on healthcare AI research. Uh, so yeah, that's about me. And yeah, Ronak, please go ahead.
Hello, I'm Ronak Sen, and I'm the currently AI associate, AML associate of GDSC AOT. So that's all about me.
Right. uh, Also, like, just to communicate with you all of you, just if you have any questions, just feel free to drop them in the chat. And we are also keeping track of all your questions. We'll try our best to answer all of your questions. With that being said, let's get started. So today we'll learn about the basics of generative AI. And as you've all heard, we have all heard about using Chat GPT, Mid Journey, Stable Diffusions, and all these things. So we'll today dive into the very basic aspects of how the fundamentals of generative AI works. We'll deep dive into some workshops, and I'll show you into a coding environment how does it actually works and how you can build your own generative AI and stuff. But we'll also discuss briefly about all the models and all the architectures that generative AI, is made up of. It's basically, creating a bunch of images, creating a bunch of text from just 2 3 lines of prompt, and that's real magic. And we'll today try to explain you what's the mathematics behind it and each and everything. uh, as you can see, that's a very basic description of what generative AI is, and all of you actually know. But we'll just skip it and we'll just get started with the contents and today's agenda. So I'll be explaining you the image generation part, the attention mechanism, and a lot of it Ronak will be explaining you about encoder decoder. And I'll again jump in and explain you the introduction to generative AI and the Vortex AI solutions that we have on Google Cloud. And yeah, let's get started for that. So, talking about image generation, now that's a very broad topic about image generation. So you must have used many tools like DALI, or maybe you have used Google's own create image generation creation tool. Some of you might have also used Gemini. So just I just want to make this interactive, and can you just type in the chat like how many of you have used image generation tools? And you can type it like what is the name of the image generation tools have you have used. Like you have also used, there is Microsoft's own image generation tool, and then you have OpenAI's own image generation. How many of you have used it? Can you just type in the chat and show? I'm waiting for the replies. Yeah. Okay. Nobody, is it? Okay. Seems like a lot of you haven't used it. Am I right? Uh, Yep, please feel free to type it in the chat, and this will be a pretty much interactive session, and it's not just a one-sided session that only I am going to explain, and you're just going to listen to it. Uh, I just want proper communication from your side too. That will make the session much more interactive. Okay, talking about image generation, we'll dive deep into how the basic aspects of image generation works. So let's talk about the fundamental thing about how image generation actually works, right? So the basic principle on this, on how this image generation actually works, is basically diffusion. So the diffusion model is something which is based on physics. It actually came from physics. So you might have used a glass of water in your chemistry lab. You put the water in your beaker, and you like kind of try to mix an ink in the water, and you might have noticed, like how that particular drop of ink in the beaker, it actually uh, turns the whole water blue, right? So that's basically diffusion. Now, why am I explaining this to you? Because this is one of the fundamental models in machine learning, and this is one of the fundamental models in physics too. And I want to explain to you how all these two things are actually correlated. So talking about diffusion, let's show you how this diffusion actually really works. So below is the image of a cat, as you can see. And how a machine learning model is trained is actually, you will be provided in the machine learning model with the image of a cat itself, and we will try to add noise in the image slowly, right? And as you can see, progressively the image of the cat itself, we're trying to add noise to it. Like in standard models, this cycle happens to over 1000 times, and this actually is very much effective, because the model is slightly learning that, okay, after this much amount of time the image looks like this. The model the first image is already in the brain of the model. The model already knows how the first image looks like, and then you go on to add some noise in this image. And now there is a backward diffusion model which actually works with this, and its main aim is to generate a particular image that is similar to the cat, and it has to generate that image from this noise, right? And that is the very basic sense, how diffusion model works. And this is a groundbreaking architecture for image generation, and it has been a lot of models has been recently deployed on this very particular principle on Hugging Face, and there are a lot of open source models related to this. So we'll explore them one by one. uh, Let me take an example, as we have this corgi playing a flame throwing trumpet here, right? So the model doesn't knows what a corgi is, or what is a trumpet here, and what is a flame throwing, right? And it doesn't also knows what is playing. But the model has been trained on images like a corgi playing a trumpet, right? And it also has been trained on certain images like a corgi playing a flame, or it might something related to the flame, right? And what happens is that, as you can see, this particular line above this is the input, and below we are classifying here as the output of the model. And what actually happens is that we have this text as input, and we have this image as the input here. And what happens in the diffusion model is, particularly, you divide this particular prompt into matrices, and you divide this particular training image into matrices. And then it goes back to the decoder, and slowly, from a zero, I mean a clear noisy image, you try to build an image from scratch that is actually pretty much similar to the training image that was already provided. So that's how a diffuser works. So that's how this diffusion model works, and it's really interesting. You might also try giving it some other prompts, like you have used in DALI or Chat GPT. So this is the underlying factor of how a diffusion model actually works. So here is a very funny and interesting thing of gold bar chilling in a beach. So this is not a realistic image, right? So this is obviously a generated image, but who have actually seen gold bars chilling in a beach. So this is how it is actually generated. It's like you might have seen in your TV screens when it used to lose signals. It used to have a complete noisy image there. So right from that position, the work of the backward diffusion model is to bring and create such images that is completely new, completely new. And that's where the term generative AI comes in, because it generates these images from scratch. Yeah, so that's about it. But I would like to hear questions, if you have any questions around this. You can write it in the chat if you have any questions around this, and I'll be happy to explain. And if you have understood whatever I have explained to you, please type yes, that yes, you have understood. Okay, I've got a question, why we need this diffusion process. So Ronak, you would like to go first?
Yeah, yeah.
Okay, sure.
So, in order to create something, we need some idea. So, what do we create? Like in the example previously presented here. Move to the previous slide, please. Like a gold, okay, like a corgi playing a flame throwing trumpet. So, the model does not have been not been trained on the particular text that a corgi is playing a flame throwing trumpet, but it has been trained on something similar like corgi playing a trumpet. So it takes the essence of what that the text has in relation with the image which was present here. So like it takes a part of the corgi's head or like a part of the trumpet, and it relates that a word this word is similar to the representation of this image. So if you can relate that, then in the new text which will we enter, it overlaps the similar patterns which it previously found. And this process works very well because it randomly creates that particular patterns all over the image. So it gradually, step by step, creates an image which have not seen in the training set. Like if we do this in one step, the model cannot do a very fine work because image is made up of thousands and millions of pixels. So we need to do this in a very few number of pixels at a time. So this diffusion, that's why diffusion is primarily needed, because images are very much complex, and to get an image of a particular prompt, we need that gradual step that this diffusion processes do. Okay, any question further?
Hope that answers your question, Tetli.
The OCD.
The question reads: the OECD recommends that AI system should be designed to be transparent, explainable, and capable of being human controlled, as in AI should be trained emotionally. Why? AI should not be trained emotionally. Why?
This is going into the ethics of AI training.
Going into
Um,
the transparent AI and ethics AI section.
uh, that AI is currently the models which have been trained in today's date and time are not only that superhuman type behavior like a human that can have. So currently it doesn't matter so much that AI to be trained in emotional data or not, because in at the end of the day they are just prediction spitting machines. They predict what will happen, or what is the word, what is the pixel of this part, means color. So mostly currently the emotional part is not important, but when we gradually increase in the complexity and the capability of the AI models, that emotional part will come in very crucial role, because if an AI can make decisions as a human, then what role do humans have to play in the process of the evolution? We create an organism that can destroy us. So it's a paradoxical type thing. It's a, a very philosophical thing actually.
Okay. Hope that answers your question. If you have any more questions, please shoot them in the chat section. And if not, we'll get started with the next topic. That is attention mechanism. All questions done? Okay. Okay, let's get started with the attention mechanism. So this is, the inner masala of chat gpt and each and every large language model that is currently in existence. This is the primary thing on which each and every large language model is actually working on. And there is a sweet paper that was published in 2017 by this senior scientists at Google Brain, and the name of the paper is "Attention is All You Need." And in this paper they have described about how you have to put weights on those particular. Okay, like seems like I've been talking for a while and I was on mute, right?
It was my bad. Actually, I accidentally did that. My bad.
Okay, okay. So was it from the beginning, or was it from which part have you
No,
not?
it's just 3 to 4 seconds. Not much.
Oh, okay, okay, okay. So
Yeah, yeah.
you've heard about what I've said about the attention mechanism, right? Okay. Yeah, so just I was saying that this attention is all you need is a paper that was released in the year 2017 by these senior super scientists at Google Brain, and it basically describes that what are the particular positions in a sentence where you need to put more and more weight on, so that the model understands that this particular sentence, this are the few parts that are more important. I'll get started with an example, but let's just understand how does this attention mechanism works. So as machine learning engineers and enthusiasts, you must have heard about softmax functions. So softmax function is nothing but it's just a kind of turns this mathematical models into kind of probabilities of zeros and ones. So if it is zero, it is false. If it is one, it is true. So something like this. And just to consider attention, whatever they have defined is based on the parameters of q, k, and v, and we'll explain what q, k, and v is. These are different parameters, and q, k, and v, and it's the attention is defined as the softmax function of q, k, and v. And whatever you can see here, this is the relation between q, k, and v. It is q, k to the power t by roots square root of d of k, and that is multiplied by k, that is multiplied by v. So just go and have a try on the research paper that was actually published. I can actually show you the research paper, that will be more helpful. And just try to show the research paper. Yeah. So is the research paper visible, right? Okay. So this is the particular research paper, and after the after they have published this research paper, things like Chat GPT and all these LLMs actually came into existence, and this is the main thing. So yeah, this is the main softmax function, that is the main, the spotlight of this whole research paper. It's a scale dot product. And now let's get back and let's explain how this whole attention mechanism actually works. And I'll just go back to that slide and I'll explain you how does attention mechanism is actually working there. I'll provide an example. So let's take an example of who am I. Okay, let's take this sentence of who am I, and let's divide it into feature maps, convolutional feature maps. If you do not understand what is convolutional feature maps, let's segregate this word as three blocks of a sentence. Who am I? And these are converted into numbers, that is in the form of a matrix, and it is presented as and it is presented to the model, right? Now how does this attention mechanism works is that this three words who am I will be transferred to three sections. So this will be a function of x, that is let's consider this is fx and gx. And what will happen is that we'll have a softmax function here, that is this particular softmax function, the relation between q, k, and v. And after that we'll generate an attention map. And what happens in this attention map is that with this particular mathematical formula, an attention map is generated. And what happens with this attention map is it provides you on which part of that sentence should you put more stress on. Maybe, please buy me a coffee, for example. This is a sentence, right? So what is the most important sentence here? Most important word here, coffee, right? So the model needs to understand that the person is asking for a coffee, right? So here you can see in this attention map, the portion in the matrix where it is the most black, it is the point where the model has stressed on that particular word coffee. And the positions that are in white sections, that is the point where the model has put less stress on, because those words are less important, right? So maybe we can say, please buy me a coffee. So we can actually say a coffee. So maybe that word a coffee, that a letter, that can have a less attention span here. And then we actually implement that attention map on the previous function of hx. So that is still the who am I sentence here. And you kind of paste this attention map, you implement that attention map here on this sentence, and then you get the resulting matrix. Now the number in these matrices which you started with will be different from the numbers in these matrices which you are ending with. And what happens is that all those words actually in the output matrix, all those words actually get highlighted. And what actually happens is that when you will train the model, or when the model will reply to you, maybe you are asking Chat GPT, please buy me a coffee. Chat GPT actually understands that okay, this person is asking for a coffee, and coffee is the most important word here. So that's all about this attention mechanism. I'll just give an example and I'll head over to the questions. So this is a famous example by Google here, which shows an English translation of French, right? So there is a sentence, black cat ate the mouse. And the similar translation of it in French is chat noir mange. And the thing is, whenever you translate this sentence from English to French, the word black cat actually is, it actually gets overturned, and the word cat comes in first, and the word black comes in second. So how do we translate one language to another, and with the help of machine learning, is with the help of encoders and decoders. Now in the model of encoders and decoders, what happens is that you pick one word, you translate it into a separate language, and then you paste it there, right? That's how it happens. But how do we implement the context of a sentence inside a particular translation, right? So here what we use is attention mechanism. As you can see, this attention mechanism actually puts the word cat in front, and with the help of attention mechanism we gain the context of a sentence. So you put the word cat in front and the word black in the second position in the sentence, and that's how this whole translation is working. You'll get a very in-depth understanding if you actually go through that research paper. It has been clearly mentioned, and it has been very beautifully mentioned there how this whole attention mechanism is actually working on. So I'll recommend you to please go through that paper. That is indeed very beneficial. Yeah, questions? Yeah, thank you, Ronak, for pasting that link there. Okay. If you have any questions regarding the attention mechanism and how does it work, please feel free to shoot that in the chat. What is an encoder decoder? Yeah, that we are coming. That is the very next topic. Encoder decoder is actually it's a famous model that was used in translating from one language to another. So I just used that encoder decoder model because it was actually used by Google to translate from one language to another. So that this is a very famous example, and in fact this particular diagram is actually created by the engineers working on Google. So yeah, we're coming to that. What is encoder and decoder in details? What is blue and green thing in the? It's just used to differentiate the two languages there, because the one you're seeing in green is that is actually in English, and the one in blue that you're seeing is actually in French. And the diagram in the right side, what you're seeing is actually the attention mechanism that is being implemented while we are translating from English to French. Okay. Any more questions? Okay. Okay, now we shift to the next topic, that is encoders, and this will be presented by Ronak. So yeah, Ronak, go ahead.
Thank you, Subro, for that wonderful talk. Now let's move to the.
I'll just keep changing the slides. You just tell me.
Now you can close your screen share.
Okay.
So, huh. The encoder-decoder architecture. What it is? You can think of encoder as translating a piece of text into a very compact form which contains almost all the information the original words has, and the decoder part which takes that compact form and translate it into the final output which we want. So here is in this example, let's take the example of how are you and question mark. So the as the ML models all works on with numbers. So the computer don't know exactly what is how, what is are, what is you. So we use an embedding process. Embedding is nothing, just we assign each word or each letter to a particular number, and we use that number to do the mathematical process to get the output. The model takes input as numbers and gives output as numbers. The embedding process is nothing but, let's say we use the number 1 as representative for how, number 2 for representative as r, number 3 for representative as u, and number 4 for question mark. So the model takes in 1, 2, 3, 4 as input. It uses the encoder architecture which implements the attention mechanism within it, as you can previously seen, and then it provides a complex matrix representation which is passed to the decoder architecture. This decoder architecture uses that matrix for to with the help of attention to get the output of the let's say first word which is being presented as I. So the model took the complex matrix representation and used attention to predict that the I word or I letter had the most probability of occurring as the first word or letter of the sentence. So the model gave the output I. Then it moves to the next part. Then the model will take the input I and the matrix, and then it will apply attention. Then we will predict that what will be the next probable word or probable letter to present. The model predicts am, as generally am comes after I, so the most probable answer is am. So in this way the model takes in the previous output which the model itself gave and the complex matrix representation which the encoder part provided, and applies attention to observe that this part has more weight, so it will be more probable that this word will be coming next. Like I am good or I am bad is very commonly used, so I am good or I am bad will be most probable outcomes. This part can be easily changed by that model training data. Say if you have training data of very optimistic training text, so the model will obviously give output which is more optimistic. If we take in very much pessimistic text, the model will also give in output very much pessimistic. The model is highly dependent on what is the training data of your training model. So that much is very small part of the encoder decoder architecture. So are there any questions? I will take the questions now. So there are no questions it seems. So we will be moving on the next part. Now this will be a lengthy part, transformer models and the BERT model. We have seen above the encoder and decoder and the attention part. Let's mix it all together and find out how it works underneath the system. So this the image you're seeing is first published under the attention is all you need paper. They trained a model which has an encoder and a decoder. The this part so the left part is the encoder part which is called BERT, and the right part is the decoder part which is called the GPT part. So we'll go deep dive into that. So first the BERT part. What is BERT? BERT has been named as bidirectional encoder for representations from transformers. So it's a mouthful. So what does the BERT encoder do? It takes in the input and uses the input embeddings. The embeddings which I have taught that how are you it translate into 1, 2, 3, 4. Like that it gives them a number representation. And there is a positional encoding, like how are you, the where is the position of the how means it is the first word or the second word or the third word. That thing is done by the positional encoding. So this positional encoding combines with the input embedding to give a matrix representation of the what word is there and where it is in the sentence. So this matrix is then passed to the multi-head attention. Now, the multi-head attention is nothing but the attention applied multiple times as different heads, because each and every run can give, it is a probabilistic model, so each and every run can give probability to different part of the sentence. So using multiple heads to figure out which sentence is the most probable is very much optimized for getting the most probable answer. This multi-head attention part gives output to the add and norm part. Now, what it is the add and norm part? it can be very much confusing. So let's go follow this network. This part is been split into two: the matrix which you have got from the input and positional part. This matrix is been added with the multi-head attention matrix, and this normalization is nothing but, uh, if the number is too big, we can reduce it to size 1. If the number is too small, we can reduce it to size minus 1. So it's just scaling, nothing but just scaling. Then we pass this the matrix output to the feed forward network. Feed forward network is nothing but a simple neural network which has some convolutional or linear pooling layers to give output with a softmax or some generally softmax in the BERT model. And the again add a norm part. Now the part we see in the gray colored box is been repeated n times. So the chat GPT which we enter that how am I or who are you, it doesn't give answer instantly or in single pass of the model. It repeats the same probabilistic model in the encoder part n times. Then it goes to the decoder part. Now in the decoder part.
Yeah, so before you go to the decoder, like we have a question here regarding this. So
Okay. Mm.
the question is that how it is predicting that there should be an am after an I. Can you repeat
Uh,
that? Yeah.
a very good question. So there is a training data. Okay. So the training data, we have seen that Wikipedia text, for example, Wikipedia has thousands and millions of text that of various person or various objects. So in the Wikipedia text, there are various English sentences. The sentences have, so you will most commonly see in Wikipedia that I am something or he was something, like that. This sentence repeats very much times. So the model has repeatedly seen the same pattern of similar words repeating one after another many times. So this is how it knows that I am must come after I, or good must come after am, or bad must come after am, like that. Have I made clear to you that?
It basically like depends on the training data that
Yes,
that the model was trained on. For example, like ChatGPT it was trained on Reddit, right?
very large. ChatGPT I think was trained on 300 or 400 terabytes of data. Means it's a very
Yep.
large data set. You need to gain go through very much text to gain the knowledge to define that am must be come after I. Means these models are doesn't means called large language models for a reason. Next, the GPT part or the decoder part of the model. GPT is nothing but generative pre-trained transform. Now the generative part, we know that it generates. Pre-trained part means we have to train it to get the output, and the transformer is just the architecture of the model. Now the this line, this small line you see here, it's got from the encoder part. We can see it clearly here. Yes, the encoder does its mathematics and gives the matrix output to this side. Okay, and we see this bottom part after the encoder gives the input to the GPT part. This bottom part is mainly used for training only. During training, suppose there is a training dataset which contains the text that who are you, and it has outputs as I am Ronnie, for example. The answer it is present in the training text. Their model uses the output embedding, means similarly as embedding before that 1 2 3 4, and it uses the positional encoding that where it is in the sentence, and combines to form a matrix. Then the similar to the encoder part, it generates another matrix which is used with the encoder matrix. It may sound like very complex at first, but it is just a pathway to follow, that this comes after this comes after this, like that. The model uses both encoder matrix and the output matrix to train the weights or prediction parameters for the attention head or feed forward or add or non part. Now you might be saying what is the parameter part or why it is training that to gain the probabilistic answer that the I am must come after I, there need to be some weights like am has this percentage of weightage if it is present after I. So these all weightage or these all things are called as parameters which are present in the model. Like GPT-2 has 375 million parameters, and ChatGPT is based on GPT 3.5, so it is much larger. And the new models like GPT-4 have billions of parameters, so they have billions of weights, or you can say as dials to know that what the model will do next. So back on track, similar you can see the similar masked multi-head attention type in various part. It does the same thing. Now you must be wondering what is this mask part. Mask part is nothing but you remove the answer from the outputs. Like there's a text that who are you and I am Ronnie, so you the text is as a whole, you give the input as a whole and you remove the who are you part, so you get the only the answer part. That is only what the mask is, means you are masking some part of the input. And you uh, do the matrix calculation similarly, like the encoder part here. And as you can see, this whole part is in the gray box which is written nx, means the decoder part also repeats the same process n times. Means just by simple we enter the chat gpt, you ask a question, so the chat gpt runs this thing n times, then does this thing n times, then does linear and softmax functions to give you the answer. So much calculations is being done by the model to give you the correct answer or the most probable answer. And you can see that output is presented in probabilities only, because ChatGPT doesn't know what is who, what is I am, what is I. It knows only 1 2 3 4 or numbers, so it outputs in numbers. And the that UI, the ChatGPT UI which we use, they convert the numbers into the English words or some other words which we know. So this is a pretty complex topic. I hope I've been able to discuss you enough. Now the transformers. There are different type of transformers: encoder only, decoder only, and encoder decoder. Encoder only also called as auto encoding, decoder only also called auto regressive, and encoder decoder also called sequence to sequence models. They're just different types. That encoder only, which you have previously seen example as BERT. There are very much various examples, and decoder only also have examples like GPT-2, GPT-3, and even ChatGPT is only decoder only. The encoding part is done else, and then it's part to the ChatGPT decoder only to give the output. And there is encoder decoder models like BART, T5, Meringue, similarly. And the task which one we see are similar but very much different. Like encoder only can do only sentence classification, name entity recognition, mass language modeling, extractive question answering, like that. And the decoder only does like text generation, casual language modeling. And the encoder decoder only does like sequence to sequence tasks like translation, summarization, generative question answering. The modern chat gpt architecture which we use uses both encoder and decoder in the backend to give you the various capabilities of various models in combined in one form factor. So before moving on to the next topic, is there any questions? I hope there will be questions because the topic is pretty complex. So there is no question as it seems. Okay, then I will be moving on to the next part. Create create image captioning models. We have seen image generation. Now we will see image captioning. Image captioning is nothing but a part of the image generation process. Like we take the image as input and that caption or text as input. Like here is a lady with a glasses, so you have to prompt face with object which has glasses. So we take this input, and the image encoder converts the image into a matrix representation. The text encoder also converts it in the matrix representation, and we combine those two metrics to form a new matrix, which we train to model to give the output that what was the uh, prompt which was provided of a given image. Like in the diffusion process, it takes the image and diffuses it to give the output of the text it was there, as it's all done in the mathematical process. So it is a very simple architecture known as clip encoder. The clip has a also has a full form, which I will show. Hmm, contrastive language image pre-training. It is a pretty mouthful, so clip is very short for that. Hmm. So clip encoder is just that we use that image and we combine with the text to get a matrix representation, which we'll use to get the answer for the particular image if the what is the present in this image. So it is a simpler topic than that. Any more questions? No more questions, I think. The next two part will be done by Subro, so you can take it from here.
Okay, yeah. So, like just before heading over to the generative AI studio and showing you how it works, I'll just like to, yeah, Ronak, you can stop presenting your screen. I just like to share you one more thing about the diffusion model that I missed. So there is a website called, yeah, I hope you are able to see my screen. So this is a particular website which I was referring to. This will help you understand even better actually how does diffusion models work, and the graphic user interface will actually help you understand here how this all diffusion models are actually working. So maybe you can see here is a prompt that was already given here by the model, and as you can see here, the image generation is taking place. And how does it actually happen? So we actually start from literally noisy images, and then slowly and slowly the work, the main of the model is to create an image that exactly matches the prompt. And this all is actually happening based on the amount of training data your model is actually trained on. So yeah, please refer to this website. This will actually help you to understand how this is actually working. So yeah, and then we are heading over to AI studio. But before that, yeah, anything that you would like to ask in the chat? Yeah, thanks for sharing the link, Ronak. Okay, heading over to the generative AI studio. So just you can create your Google account, Google Cloud account, and Google Cloud gives you uh, access to around 30,000 rupees worth of Google Cloud credits. That is, yeah. So this is around $300 in free credits. Just enter your credit card and you'll get. I think this is also without the credit card. This is our company's Google Cloud account, and I'll show you how to get started with Vertex AI. So just type console.cloud.google/vertex AI and you will be here. And you can see that there are a large number of models that you can actually use in Google Cloud, and this will help you how to use these models. And we'll just get started, and I'll just show you an overview. We have some quick running codes up here, and I'll just run them and show you how it actually works. So this is one of the cloud speech to text models, and if you actually run these models, these are pretty good models. You can just draw these APIs, and you can use them in your own GitHub projects, where you can maybe do with a live speech to text translation. Okay, in your own projects, you can just draw these APIs from here. And then we have this Vertex AI Studio, and yeah, this is one of the famous coding examples I wanted to show you. uh, this is Google Cloud's own vision code, and let me just show you. So this is these are the links to two glasses. Yeah, so I just click on this link, and you can just see these are the two links of the glasses. And in this Python program, I have just mentioned that these are the links of two glasses. And in prompt one, I have asked that which of these glasses you think is best for my shape, and I have mentioned that this is the shape of my face, that is an oval face. And the return I get is the glass one. And next I ask them, like, how do you reach this decision? And uh, this generative AI model actually does a pretty good reasoning that the glass 2 is actually better suited for this oval face. And you can just try on this lab. So this is pretty much interesting, this Colab Enterprise. You can just try on this lab, and it has a lot of inbuilt code here. For example, when you just go to tutorials, you can actually find a lot of example code here. Just go through them, try to run some of the cells. It will actually help you increase your knowledge in Python and generative AI. These are really helpful materials. Just go through them. Just go to cloud.google.com/vertex AI, and you'll be there. That's about it about the Vertex AI, and we'll now head over to quiz section. But before that, if any of you just have any questions about Vertex AI and generative AI in general, we'll be happy to answer them. Please shoot them in the chat. Okay, seems like my screen is visible now. The one who will answer the question correctly will receive a swag. So time starts now. I'll just check the chat box. Who is actually putting the right answer here? Yeah, waiting for the responses. The question says, which company created Gemini model? Just be diligent and just don't Google it. Anyone? Okay, okay.
The hint is in the image. The Gemini above the eye, there is a hint.
Okay. So two people saying the answer is Google, and one saying the answer is OpenAI. Yeah, Ronak, you can go ahead and tell the correct answer.
Correct answer is Google. That
Okay.
in the Bard logo, there is an image, the star image, that it is present in above the eye in the Gemini logo.
Okay, let's head over to the next question. And there is a very good question at the end. So please stay till the end. What is the machine learning architecture behind Chat GPT? GPT as in generative pre-trained transformers. And so the question is, what is the architecture behind Chat GPT? And the full form of Chat GPT is generative pre-trained transformers. Okay. Also, like for the previous question, Ruchi and Rashmi Datta, both of you will get swags for the correct answer. Anyone, anyone? What is the correct answer for this question? What is the machine learning architecture behind ChatGPT? Okay. Seems like there is no responses. Are you sure? Okay, okay, okay. We got one answer. Abhiraj. Okay. Abhiraj says the answer is transformers model. Anyone else? Okay. One more answer I got. It's diffusion model. Okay.
Hint was in the name.
Yeah. As I previously said, what is the machine learning architecture behind ChatGPT? And the full form of GPT is generative pre-trained transformers. So the answer was inside the question itself. Okay, Abhiraj, you get the swag here. And coming to the most important question of today's session, now you have to identify this which of these images are actually AI generated. So, two of these images are actual real portraits, and one image is actually created by generative AI. So, you need to answer me which of these images are generative AI created. Okay, as a number one, two, or three. Just a small hint that the generative AI created image will always be different from others. Yeah, it will be different from other portraits. Okay, okay, I got two answers telling me that the image in the middle is the fake image, right? Okay, the fake image is the image in the middle. Okay, everyone. Okay, okay. Seems like AI has to do more, lot more hard work to replace human beings. We still value real portraits. Okay. So yeah, thank you so much for being with us in this session. That's about it. If you want to connect with me and Ronak, please scan this QR code. You can connect with me on LinkedIn. It's linkedin.com/shubhra Kamal, and it's linkedin.com/Ronak Singh for us. Uh, you can just go ahead and connect with us, scanning this QR code. I'll just leave this for a couple of minutes. That's the end of session. And yeah, thank you so much for attending this session. And by the time, if you have any questions, please feel free to hit the chat button. And also please hit the solution challenge link of Google Developer Student Club, AOT. Raja, I think you should just paste the link here, right? We can just paste the link up here.
Definitely, guys. So let me share with you in a moment.
Okay, Ronak, we also got a question like what is black box and what is the use of it? And also, along that, you can also tell that what is white box and why it is getting implemented in transparent AI or explainable AI nowadays.
Black box is a theoretical construct that you build a system and the implementations of the system is hidden from you, like that is what is generally defined as black box. So before coming to the session you always thought that chat gpt gets some text, returns some text. Now you know what happens. Now means there are very complex mathematical things which is doing underneath. So that is which you can say that white box, that you know the inner workings of the how the machine works or how the model works. So in that sense it is called white box or black box.
So, like basically, there are places in a neural network where you are not able to, segregate what actually the neural network is learning. Like you are not able to find the learning patterns of a neural network itself, right? So, for example, we are training a neural network, and we are training it to, learn the images of differentiation. Like how to differentiate between a cat and a dog, right? So obviously the neural network is built with a couple of mathematical functions, and we are not able to know what goes inside the neural network, right? I mean, like we are not able to predict like in which particular layer is the neural network predicting that okay, this is a cat and this is a dog and all this. So that's basically a black box. You are not able to understand what actually is happening inside the neural network and how is it making those decisions. And to better improve on those decisions, we also have a system called explainable AI, and we use tools like Lime and Shapely inside the model building, so that you can actually get what the you can actually build out the inference of each and every layers, like what each and every layers is actually trying to say, right? So that's about black box, and that's something about explainable AI. So all these things are actually interrelated. Okay, I think Raja just okay, did you share the link, right?
Now you can just refresh the presentation after the connect with us. I've given the slide.
No, no, I'm just asking, is the solution challenge link already shared there?
It is in the slide
Okay,
presentation slide. You have to refresh it.
all right. Yeah, any more questions, please tell them in the DM, or you can also connect with me and you can ask after this session. Okay, you can just scan this link. This is the link to the solutions challenge from GDACOD. Okay, that's about it. And yeah, thank you for attending this session. Uh, I hope to see you all in some other session of machine learning that will be soon conducted by GDACOT. Until that time, stay tuned. Thank you.
Thank you.